Hello, pre-calculus scholars. It's Mrs. Gregerson, and we're learning the law of sines. Now, our previous unit was all learning the unit circle, how to work with quickly the sine of 30, the cosine of 60, tangent of 90, 45, all those very quickly, and also being able to solve for the different sides and angles of right triangles. Well, the thing is, there's more triangles out there than right triangles. I mean, very simple to see why, right triangles range to the plane, they have a right angle. But we know there's a lot of other different type of angles. We know there's acute angle triangles. We know there's obtuse triangles. Well, any of those triangles that are not right triangles, they have a special term, and that's called an oblique triangle. Now, in order to work with oblique triangles, there's a few things we got to make sure that we know well. One of those things that we need to make sure we know well is how to identify opposite angles and sides of triangles. So if I have a triangle right here and I go A, B, C, and identify the angles, is that we need to be able to identify their opposite sides very quickly. So like the opposite side of A is the side that's not making the angle itself, so this would be A. The opposite side for angle B would be lowercase b here, one that doesn't make the angle itself, doesn't touch it, and then C. Those will help us really huge and be able to identify the different parts that we need of an oblique triangle. Now, we have two different ways of solving for missing sides and missing angles of oblique triangles. We have what are called the law of sines and the law of cosines. So today we're only going to be working with the law of sines. Now, I'm going to explain to you how the law is derived. Understand you're not going to be held accountable for that. It's more like, can you actually do the work with it? But I hate for you not to know, where did this formula come out of thin air? I don't want you to have that. So we're going to use some ideas that you remember back from geometry. Do you guys remember what an altitude is, right? An altitude is just a segment from a vertex of a triangle that goes straight down and is perpendicular to the line containing the opposite side. Every triangle has like 3 altitudes. And we talk about the height of an altitude, and that's why we use the lowercase h. So you see in this diagram here, for my triangle ABC, make sure I highlight it here, that blue dashed one right there, that is the altitude from angle C to side AB. So that's where we get this. So understand I have an altitude. Now I'm going to use that altitude because the moment I put it in that a big oblique one, that yellow triangle, you're going to want to realize that I'm going to draw an altitude in it. And the moment I do that, what type of triangles do I form? That's right, 2 smaller right triangles. So we're going to look at the triangle on the left, and we're going to look at the triangle on the right. So using the triangle on the left, I'm going to use the fact that I have angle A right here because it's not the one that's getting messed up by the altitude being drawn. And I want to find the sine of angle A in, and let's just say small triangle to left that I'm setting this up from. So I'm like, okay, using the small right triangle to the left, I have the sine of angle A is going to be what? Remember, sine is opposite leg over hypotenuse, and so that's going to be h over b. Now I'm going to solve for the height. All right, so I solve for the height, and I get b times the sine of angle A equals the height length. So again, we're just manipulating the equation around in order to do that. Now, I'm going to do the same thing over here to the small right triangle on the right. All right, so this one right here is the triangle we're working with. Now, I'm going to look at this one, and I see angle B. And I want to find the sine of angle B using that triangle on the right. Notice when I do the sine of angle B, I get opposite leg, which is h, over my hypotenuse, which is a. So I get h over a. Then I solve for h again, and I get a times the sine of angle B. Now, what's the thing do I know about h? For both of my equations, this b times sine of angle A equals h, and a times the sine of angle B equals h. What's so special about h? Well, h is the exact same segment. So doesn't that mean that I should be able to set these two equations equal to each other? So now I can sit there and go, all right, b times the sine of A is equal to a times the sine of B. Now, that doesn't look like really exciting and everything, but I want you to notice I took the H away. What only letters am I using besides the word sine? A, the segment A, little a, the angle, then I got segment little b, and then I have B, the angle. And so I want to write this in a proportion format. So what I do is I'm going to try to get things to kind of match together. So I'm going to divide both of these by sine of A, both sides of my equation. Now remember, if I do it to both sides, I'm not making the equation wrong. I'm just changing what it looks like. And then I'm going to divide both things by sine of B. Now look what happens with my sine of A. It's gone on the left, and I get left with B over the sine of angle B equals to, or as, if you think of a ratio, B is to the sine of B as. Well, look what happens to the sine of B on the right. It leaves A over sine of A. Now, guys, isn't that really cool? Notice I have a proportion that literally matches my opposite sides with the sine of the angle that's opposite that side. So I got B is to sine B as A is to sine A. Now, do you think I could do the same thing if I maybe drew in a different altitude and I could do this with angle C? And the answer is you can do the same thing. You can do same process with a different altitude. For angle C and C. So really I could set up a proportion. Well, that proportion that I could set up is called the law of sines. So notice my law right here. The law of sines for triangle ABC with side lengths A, B, and C are the following. And I'm going to try to use this to match up. We know that A is to the sine A as, we're going to keep going here, B is to sine B as, and then C would also match then, as C is to sine C. So that's the law of sines. Now the cool thing is you'll only ever be using two of those ratios. So you're only going to be like A over sine A equals B over sine B, or you can say C over sine C. You only need two of those fractions equal to at a time because I can use it to solve proportions. Now you can write it as reciprocal. So I learned it as this way: sine A over A, sine B over B, and sine C over C. I learned it that way. But it doesn't really matter because, again, we all know that reciprocals are just the flipped over version and everything would be flipped over. So no, it can be seen both ways. Now, there's only certain times, though, that you can use law of sines. And that's when you're given any two angle measures and a side length. Now, if you remember proving triangles way back when, we used initials to represent what information was given on the diagram. And we would use what was called angle, angle, side. So I'd have two angles and a side not between them. Or we'd have angle, side, angle. Well, where's the side located? Between the two angles. And so that would be one way we'd identify the different parts of a triangle. So if I have two angles and a side given, or I have two angles and a side between them given, we can use law of sines. Or we can use it when we have two side lengths and we have a non-included angle measure. And so that was side, side, angle. So what I mean by side, side, angle, so I have something like this. Let's say I have this 40-degree angle, and I know this side is 10, and I know this side is 8. That would be considered side-to-side angle. Side, side, angle. Now, here's something about side, side, angle we don't talk about. This is called the ambiguous case. What means, the reason why you never could prove triangles by side, side, angle is the problem that this side right here, we don't know where it's exactly landing on the side opposite. So this side right here, I don't know where it's landing because since I don't have an angle between them, I literally could redraw that side of length 8 going this way on my triangle. So this would be 8 and this would be 8. Now, I don't know if I'm given a side of 8, a side of 10, and an angle over here, A, let's say 40 degrees. I don't know if this should be here or if I should put it back here. So that means you could have one angle here or one angle here. I don't know really which one to use. Well, your calculator only gives you one. The other part of it over here if you notice that's supplementary angles, because the two of them make a line and be supplementary, I could use supplementary angles to solve for the missing one. So the thing is, you really are only going to ever calculate one, but we need to know that there could be another case, the angle over here, I can work with. So use supplementary angles to do that. We're only going to ever solve for one angle, the one that your calculator gives you, which most of the time is this one over here. So just know that that's the one that they give you. All right, so does that make a little bit of sense? Probably clear as mud. But honestly, the best way to learn this is just setting it up and let me help you guys get through that. So first of all, what we're going to look at when we look at a triangle, we're going to look to see what three pieces of given information is given to us. And then that will tell us if we're going to use law of sines or law of cosines. Now today, on purpose, I made it so we are always using law of sines. But let me show you what I mean. Look at this first diagram here for example A. Now here's the rule, round lengths to the nearest thousandths, angle measures to the nearest degree. If I'm giving this, this would be considered angle, angle, side, because the side's not between the two angles. And remember, we have angle, angle, side is one of the ways that we can use law of sine or cosines. Now, remember a few other things about that. So remember this was angle, angle, side, so it works. It is okay to label opposite angles inside. Like I know this would be A, this side would be B, this side would be C, right? Now fill in all the missing information for this triangle, and we're just going to use law of sines and law of cosines to do that. Well, A we know is 110 degrees. We also know that angle B is 19 degrees. Now guys, how can I, without having to calculate anything, find the measure of angle C? That's right, we're going to use the fact that the angles of a triangle add up to 180, and we're just going to go 180 minus 110 minus 19, so that's 180 minus 129, so 129, I was blanking out here, it should be 51 degrees. So I know this angle is 51 degrees. Now though, I need to solve for the missing sides. I do know that for angle A, right here, I'm going to go here, oops, wanted to go right here, oops. Sorry about that, guys. That should not have shown up on my tablet mode. Oh, my email came up through anyway. That was strange. All right, anyway. I know angle A goes with side A, which is right here, 14. I know angle B will go with side B over here, so I'm going to change that to blue. How about if we solve for that first? Now remember, I just need one angle and its opposite side and another angle and its opposite side to write the proportion. So here I got, remember we're really doing this, A is to sine, oh, let's use a different color here. A is to sine A, as we know side B is supposed to be to sine B. That's using the law of sines. Now again, I only picked the two I need. All right, so now I put in, what do we know what A is? Well, we know A was 14. Sine of A, well, what's big angle A? That's 110, so that's sine of 110 degrees equals B, which is, we don't know, so that's going to be B here, over the sine of angle B, which that's 119 degrees. Now, how am I going to solve for B? Well, that's right. I'm going to just get it by itself. So if I'm dividing by the sine of 19 degrees, all I have to do is multiply by the sine of 19 degrees. And I'll be able to get this length of sine B. So guys, it really does pay to use on your calculator. Go alpha y equals, and we can go sine 19, make sure you close out your parenthesis there, times 14, or you go 14 times sine of 19, which is another easy way of doing that, over sine of 110, and that's going to give you about, to the nearest thousandth, 4.850. Now that's not too bad for us to do. Now what if I want to solve for angle C? Okay, well the one thing I do know for certain is I know A and sine A, so I'm going to do the same thing here. I'm going to go A over sine A. Now this time we're going to do it for C though. I know I can go C is to sine C. So what do we get here? We're going to have 14 is to the sine of 110 degrees is the same thing as 50, oops, C is to the sine of 51 degrees. So just like it is, we still used our law of sines. I set up a proportion. I'm solving for lowercase c. All I have to do is really go 14 times. I'm going to rewrite it this way this time. 14 times the sine of 51 degrees over the sine of 110. So we're just solving it. Again, put it in your calculator, and you can literally go 14 sine of 51, close that out, hit enter if you wanted to, divide it by the sine of 110. And for this one, I get about 11.578 for its length. Now, most of the time, I'm not going to ask you to solve for every missing thing, but you could be asked on this, and you should be able to do it. Now, here's the thing. I tell you this works for oblique triangles, but guess what it also works for? It still works for right triangles as well. But the kind of like, why do we waste our time on right triangles when we already know the 3 trig ratios work perfectly for it? But no, it really does work for any triangle. But using the law of sines and cosines for right triangles just is like a waste of time. Now, for these below, what I did is I'm actually just solving for the missing part when you're doing this one. So on B, I got to decide what I have given in my diagram. Well, first of all, what's given in our diagram? We're given an angle, and a side. So really we have angle, angle, side, so we know that is going to work. Now, where is H? Well, I'm looking for H. It's really length of segment FG. So I have H here and its side. Now, do I have another pair of opposite sides of angles? That I know, and yes, I do. I have F, and really you could say little f right there. So how could I write this formula so it makes sense? Well, I do know that H is going to go to sine H. So that's really like going A is to sine A. Opposite side in angles, we just use the letters that are given to us, is the same as F is to sine of angle F. And then we just plug in our values with this one. So on the first one we have H is to, oops, sorry, didn't you change the colors like I thought I did. H, which we don't know because that's length of segment FG, is to the sine of 32 degrees, because that's the measure of angle H, is the same thing as F, which is 40, is to the sine of 39 degrees. Now, how do I solve for H? Well, isn't the easiest way to solve for H is just multiply both sides by sine of 32 degrees? And the answer is yes. Now, notice, guys, I'm probably showing more work than some of you would like to show. Let me put it this way. You're more likely to get it right if you show more work before you plug it into your calculator. And then if you, excuse me for a moment, guys, because I want to pull up a calculator here for you. Here's my thing with the calculator. Let's see if it'll... I would put it exactly as you see it on here on your piece of paper. So if I was doing this, and I'm going to move my calculator over here. Why aren't you going to do, I'm going to clear my screen and go alpha y equals, go number 1, and literally go 40, and then go sine 32, close it, over sine 39. Now I'm like all nervous now because I didn't check to see what mode I was in. Oh, it says we're in degree mode on top, so good. And what do we get for our answer for the side length? So H is going to be, oh, what do we have here? Sorry, got to check to see what it was. 33.682. So 33.682. Now that wasn't impossible. Maybe not fun, and maybe you have to show a little more work, but it still makes it very doable that we can solve for the missing sides and angles. Now let's look at the next one. Now notice what given information we're given. We're given a side, side, angle. So side, side, angle. Again, don't misspell that. Naughty, naughty of you to think otherwise. But I do know which sides I go. P and little p go together here. And I'm looking for the measure of angle Q. And so I need to make sure I know its opposite side, which would be right here. So that would be little q. and that'd be little p, right, guys? So we can easily set up a proportion again. So what are we going to do? Well, we're going to end up having little p is to sine of p is the same thing as q is to sine q. So with this, what's little p? Well, that's 8 is to the sine of 51 degrees is the same as 6 is to the sine of q. Now notice what we're looking for this time. This time we're looking for an angle, but first things first, let's try to solve for it. I would say cross multiply first. So I'm going to get the sine of q times 8 equals 6 times the sine of 51 degrees. Then I'm going to divide by 8. So I get sine of q is equal to 6 times the sine of 51 degrees, all divided by 8. Now, this is where this step comes in. I'm looking for the measure of angle q. Well, to find the measure of angle q, I do the sine inverse of everything that you saw up above here. So 6 times the sine of 51 degrees over 8. Well, this is where your calculator again comes in handy. So on here, see, I don't know if I can get this small enough so I can see it. No, I don't think it's going to help me on here. If I move it to the other side. Nope. Sorry, different calculator, guys, for you. Just go second sine on your calculator. I'd go alpha y equals and literally put the fraction in there. And so then I get 6. Then we get the sine of 51 over 8. Hit enter. And I got q to be about, and you don't need to use the approximate symbols, you can do equal sign because we're going to round to the nearest degree, would be about 36 degrees. Now, it literally should look like that on your calculator, guys. Let me just show you again what I did so we're all on the same page with this. All right, calculator up again. I think I closed it. Now it has to open up. With this one, close, clear this. All right. So how did I do this on the calculator? I just want to make sure we're all here. Everyone is experts on this. We're going to go second sine. I'm going to go alpha y equals to get 1 and get my angle up there. I'm literally going to go 6 sine. Oops, clear that last part here. We're going to go 6 sine of, and that's where I'm going to put my 51 degree angle, over. And if you got 8, and since we're not going to be, and if you wanted to, you can be really cool and close out your parentheses. You look cool because it's just like what's on our page. Hit enter, and you guys should have got, again, 36 degrees. So that's what it looked like on my calculator in order to solve it. So that would be 36 degrees. That's solving for an angle. So that's a little more work, but still very doable if we have our calculator. So let's look at our next one. So here we have 39, 88, 22. So I have an angle, and I'm given a side. So we're given angle, angle, side, so we know we can solve for it because we have 2 angles and a side. Okay, I'm looking for little m here, little m. So I know these are going to be my opposite angle and sides, but I'm given which 2? I'm given n and little n. So really my proportion I'm going to use this, because I can use the law of sine, is I'm really going to go m is to the sine of m as n is to the sine of n, so angle n. And then we just plug in our values. So what do we get? M I don't know, but I know the sine of m is 88 degrees. So sine of angle m. Then I have n is 22, as I should be writing down the numbers, 22 is to sine of 39 degrees because they match. So how do I know 22 and 39 go together again? Because they're opposite angle and opposite side. Now I have to solve for m, and it's really quick. I just multiply both sides by sine of 88. So I get 22 times the sine of 88 degrees over the sine of 39 degrees. All right, so again, alpha y equals, so you get 22 sine of 88 over sine of 39 degrees equals, oops, I just totally messed up on something on my calculator. So 22 sine of 88, enter, divided by sine of 39. Excuse me, now I got the right answer. M is going to end up being 34.937. All right, so again, that's how we find the missing sides. Now you will have your quizzes are going to be more like this. Your book is going to be a combination of the two. Now the book, what's different about the book than A, B, and C is they're just going to have everything labeled A, B, C instead of different letters and angles. There is a couple problems on the homework, at least one that I know of, that you have to solve for all the missing sides, like this first example here. But let's do one last example where we're solving for a missing angle. Like I'm looking for this angle. We ask ourselves what's been given in the diagram, and we were given a side angle. So side angle. Again, don't misspell that. So we know we're looking for this angle. Well, what is the side opposite? Well, that's 4.3. And then I know my other given sides that are opposite of each other are my angle and side is 50 and 7.6. So I'm going to set up my equation. So that's going to be little y. I know here I'm going to get x is to sine x is the same thing as y is to sine y. Well, little x is 4.3. And sine x is going to be, I don't know what it is. We're going to go sine x. And then we have y, which is going to be 7.6, is to sine of 50 degrees. Cross multiply. 7.6 times the sine of x equals 4.3 times the sine of 50 degrees. All right, I'm going to get x by itself, remember, so I'm going to go sine of x. We get 4.3 times the sine of 50 all over 7.6. Now, take the inverse to solve for the angle. So x is going to equal the sine inverse of everything right there. 4.3 times sine. By the way, my handwriting's really bad on this. Tell me I'm done with the video. Times the sine of 50 degrees all over 7.6. All right, again, you can put that in your calculator. I'm going to put up my calculator and not show you how to do it on this one, but remember you got to go second sine. I'm going to do my alpha y equals on this one, so I get 4.3 sine of 50 over 7.6. And you should get x to be, this makes a lot of sense. X is about 26 degrees. Now think about this for a moment, 26 degrees, is that reasonable? Remember 50 degrees is opposite 7.6, so 26 degrees should be opposite a smaller side, which it is 4.3. So it gives me a reasonableness of answer. All right, so quick reminders for what's going on. You have homework from book. All right, so from your textbook, your new textbooks. So this one's straight from your textbook. Let us know, either Mr. Smith or myself know if you don't have it. You still have your online quiz Monday night. That doesn't change. However, for off-campus learning day, okay, you have an Academy Central grade Central quiz that will count as a homework grade. You can take it as many times as you want, and it's all about doing law of sines. Okay, so all about doing law of sines. And so it's really just doing like an extra 4 homework problems, and there's one question about the notes. So that's what you have to do over the weekend. So when we see you on Tuesday, we expect homework from the textbook to be submitted online. We expect the online quizzes to be done. Okay, remember that opens up on Thursday nights anyway. And then online quiz is going to be on Academy Central. Oh, by the way, the online quiz for the online off-campus learning day one, the Academy Central quiz, which is a homework grade, it opens at 4 p.m. on Friday. Okay, so we're hoping that it takes you no longer than 30 minutes at most, 20 minutes at most to do these problems. Don't be afraid to contact myself or Mr. Smith. I think both of us will be in Tuesday morning before school. I know I have a meeting on Tuesday morning, but we will be more than glad to answer your questions in class too. So thank you guys. Hope you have a great day. Get your homework done.